How's it going, everyone? Welcome. I'm Gonzalez, and today let's take a look now at the rules of hooks and what is this thing after all. Now, uh, I definitely gonna make a quick recap of how do I get here, just to have a little bit of context, and this is also useful, especially in any programming language or any task that you're learning, whether if you are new to the software development or if you already have several years working with this on in a particular industry, whether it's on real estate, finance, aviation, software in itself, you name it, right? So that's why I'm going to make a quick recap here, to briefly describe is what is React and why React come up here, which is it was a tool developed by formerly Facebook, now renamed or rebrand as Meta, because they have a particular problem when they have all of these different UIs. And as you can see, is all of these different elements here, these user interfaces, okay? And when they need to synchronize a piece of information across all of these different UIs, using the MVC model, which is the way of how you build now applications in the early 80s, right? When you have now the model, aka the shape of the data, the view, what is going to be rendered, what the user is going to perceive, and then you have the controller. So what is the pipeline or the computation that needs to be processed in order to inject that data into user in a meaningful way, into the UI, so it can be perceived by the user in a meaningful way. So the R&D at Facebook say, hey, you know what? It'll be much more easy and makes sense to have a particular state that all of these different UI can sync upon that, right? And this is, we have things like a particular architecture patterns, which is a fancy way to say, hey, we have this systematic approach of doing things. In this case is to update a particular state, and once you update that state, it's going to be reflect those changes across all of these different components that use them, aka the user interface. So it is interesting to understand this, because you can also take a look at a video conference at Facebook in 2013, where a bunch of software developer back then, one of the key things that they mention is that they don't want to miss over the last 60 years of software R&D. So what they did is just to leverage on top of that. So what does it mean is that React initially started as as a thin layer of JavaScript that wrap all of these different HTML elements, okay? So we can now once we call that JavaScript function that is wrapping all of these different HTML inputs, we have now a JSON, aka a data structure, that describe is the UI at that moment, all right? So that's quite interesting, because we know what this things is all about, right? So anytime that you, for some reason, needs to create your own React, all right? So what you do is just to receive is the input or an HTML tag, right? And then append all the properties that you're receiving in these functions, and then return now is a JSON that describe is the current UI. And this is exactly what we look here by creating our own React from scratch, okay? And because this can be quite tedious doing so for every HTML element that you might have, that's why we have a markdown language called GSX that help us to focus is on writing is the markup, all right, combined with the logic with the JavaScript, and make everything in one single file. And if you need to add some style, you can do that also in the same file. So this GSX, in contrast with HTML, it has now a particular way of defining is the attributes and some properties and also some markdown. Why? Because at the end of the day, this is not HTML or JavaScript or CSS. This is now this combine all of this. So in terms of now, look at how you can create these UI elements and look at the difference from HTML and the template languages. So for example, like Blade from PHP or Liquid from Ruby use on Shopify's applications. So now we are reusing is the JavaScript to handle logic, which is great, instead of creating our own mini set of language, which is what happened with these templated engines, right? They have to create is a templated language to handle common things that JavaScript, at the end of the day, it does. Hey, how do conditionally rendering elements, or how do we list or rendering a collections of elements, right? So in this case, React also provide now is some convenient features like fragments that instead of polluting the global scope or the HTML done with a lot of this HTML or a lot of this div, and at the end of the day they need to wrap some children components and so on and so forth. This is the way how you can now create these containers that show some specific content to the user and so on and so forth. So we have now fragments that React handle that or handle those cases for us. Okay, and then well, how can we now organize our code here? What is the structure of this kind of web applications, right? Which is the index or the entry point of our application. Here you describe is the CSS that you want to attach to. The other is the place where you're going to mount if your React application into the DOM. And another file is the app home. This is relevant for anything related to React. So context, providers, and so on and so forth. And then you have now the ES model or the component or the function that allow you to describe is this user interface. I also look at the anatomy of this component, and now because we are creating is components in this way, so this is now some known as the component-driven development. But the TLDR is that you're going to have now is your components or your user interface defined as a function, JavaScript functions, and return now is a markdown. And if you want to apply some style to it, you can do that. So I also look at the most common things that we do in for defining this user interface, all right? So for example, stuff like receiving props to render that, or to render children elements, which is a property that is in HTML, and also is the way of how you can now modify certain attributes in these components in your HTML tag. And how you can now is rendering a list of elements using map operations, which is come from array syntax like. What are the trade-off of using that? Why do we don't care, depend on the use case, to rely on the index as a way to sort this component? Because at the end of the day, React need to keep track of that. It doesn't do that automatically. If you think about that, it's something that it might take quite amount of efforts to keep track all of your elements. So it's now delegating that to the user, okay? So it is up to the author. It is up to the author of the code to decide when to or to decide the order and the IDs of those components, right? So React say, hey, we're not gonna handle that. We're not gonna take care of the order here. You as an author of your code, you're responsible for that. And then how can we now is rendering is conditional elements, right? Whether it's using the if or the early statement or using the double ampersand to conditionally show elements like an if statement in your template, or the ternary operator like an if and else statements in your components. And also how you can now apply some styles to your React components via the CSS model. This is useful because you can define now the all relevant CSS for that component without putting that inside of your GSS file, and then now map each one of those CSS selectors and apply that when you see fit in your React component. So this is just the introduction of React. And then let's take a look at the working with state or the interactivity here. So traditionally, because on the web, to do that, to detect now some user interactions, the browser actually is like this little mini private investigator that track every little thing that you do. So two ways to do so. Or you pass a function to an event listener that attached to an element, right? And that event listeners depend on the event, so you can now respond or pass a callback or a function to respond to that event and do something that you need to, right? So for example, let's say if you're now so you are moving the mouse, right? And then you want to detect once the mouse pass through this, all right? So once the mouse enters in this, so once the mouse, right? Once the mouse enter into here and then click here, right? You want to know is when that happened, right? So for example, you want to figuring out is how much engagement this particular section has. And this is entering to the realm of marketing as well. So the technical aspect that I'm learning here is because it is also useful in other domains, and we are not separated. This is part of the overall goal. So you have leadership, marketing, sales, operations, technology, and legal as well, because there is a lot of compliance, especially if you're building an application that live in a specific region. In any case, so going back here, okay, is this right? So, or you either attach an event listener to a function, or you pass now, or you call a function directly in the HTML tag. This is the way how you deal with events without React. But in the React way, it's saying, no, because I am the one who's going to call those handlers or your functions for you. So you pass me now a reference, and when I detect now a change to that, I'm gonna call the function that you pass me here. This is what we pass now on all of these event handlers is a function reference. And this is something that Martin Fowler mentioned when it separates the difference between a library and a framework. And you might wonder, why do I even care about this? Well, because as you evolve, as you start to understand and mature in the software industry, you're starting to realize there's certain patterns that happens here. So for example, a library is when you call your functions directly, all right? And a framework is when your functions are called for you. So React now actually entering into this domain, despite that it say that this is a library for user interface. But to be more accurate, we're according to Martin Fowler, which is what we can observe in React, it say, oh, it makes a lot of sense that here is React is this framework that is calling these functions when the user detect an event. So far so good, because as we explore and understand the React, the way how we detect or respond to user events in React, and without it, also is, hey, how can I, for example, add interactivity to this component? All right. So, for example, let's go to create now a counter. All right. So, how can I add this kind of interactivity to my components, to this user interface? So it turns out that now React expose is an internal hook, aka the user state, that now is handle that state management and aka updating the UI property without us having to rely on that. All right. So without us having to directly manipulate is these DOM events or these DOM elements. So the core loop here, which is the user state, it is made of three phases. So first, it is made of three phases, right? That happen in two scenarios. So the first, when your app is loaded, now what happened is on the trigger phase, React is going to create all of these elements for you via the append child. All right, it's going to create now the DOM structure, and the DOM can render that by passing it through the critical rendering pass, which is a mechanism for browsers to transform HTML, CSS, and JavaScript into pixels on the screen. And then this is the first phase, the trigger phase. And then on the render phase, which is the trigger and the render, the trigger detect is in which scenario we are. Hey, we are on the initial phase or the initial page load. All right, let me create all of these different DOM elements via the render function, okay, or the render phase, and then attach those elements into the DOM. This is on the first scenario. And the second scenario is when a component change, I'm going to detect which components trigger that. And if that component contains more React components, I'm going to continue call that until there is no more components. And on any call of those React components, I am creating is this JSON object that represents the UI of the elements. So after that I create that via the rendering, which is the process of figuring out the new state of the UI, the snapshot here, and to also figuring out the different, what changed, because on the commit phase is going to now apply those changes to the DOM, and the browser detects those changes and refresh the UI to match those pixels. So this is these two scenarios, and in each one of those scenarios you have now these different phases. Okay, why this is important? Because as you can see, and I saw, is it is important here to understand that at the end of the day, software engineers are developing series of steps. Is this systematic thinking on doing something specifically, right? So this is the core of all of this. So what is the mechanism when you are, for example, is creating your HTML elements, or defining is the CSS, or the style in your website, or defining the logic in your application, how now JavaScript behave, right? And then now with React. So that's why I'm a huge fan. Sorry. I emphasize with bold characters here that if you want to have a long and prosper life here as a developer, as a web developer, you need to understand these fundamentals. And again, it's because if you want to, I'm saying this is, if you want to avoid any suffering here as a web developers, understand the fundamentals, period. No matter how a lot of these fussy words come out here with AI or lovable or you name it, right? So you need to understand is the fundamentals, because now you have a clarity which is useful and required in this industry, and I will argue for any industry, if you want to be the top in your field. So you don't want to get lost in a lot of this noisy stuff here. So in any case, so here is the hooks, the core loop, all right? And what is the difference between now the render and the painting? So here React refers to rendering as the process in which it spot the difference between two state of the UI, and then on the commit phase is when to apply those changes to the DOM. So unlike computer graphic applications where rendering means to take an unprocessed raw data and to speed up an output, right? Usually a 2D image. That's not true here in React, right? So this is the subtle difference between rendering in React and rendering on computer graphic applications. So the other things that are relevant as building user interface is how do you handle with forms, okay? So because when you create now an input, and because input has a wide range of possibility, right? So you have now input text, input text, cell, password, date, all of them behave the same, but select or context area or radio or checkboxes, they behave quite different in terms of how you can detect and when the value changes and then update that properly. So React say, okay, because this is something that we're going to deal a lot of the time, I'm going to create now is a simple, convenient way to detect those changes. So they create now the on change or on input, and then attach the value. This is true for inputs, select, and context area. But for radio buttons and checkboxes, where the value here is if it's true or false, so I also look at how to handle in those scenarios. And anytime that you want to control is the input with React, known as control inputs, you assign now a state to that. So you assign is the state, and when that changes, the handler, all right? So again, I also look at a couple examples, how you can do that and attach that. That to me was quite interesting and revealing. And then how do you now is handles is complex states here, right? In other words, is that how do you now compare, or how do you now compare is when you now hook into React with the user state, how do you compare is if two objects are different. This is when you need to understand is JavaScript, right? So in other words, when you have is primitive values, numbers, kind of undefined, null, or undefined, or kind of emptiness, null or undefined values like booleans, strings, or numbers. So to spot the difference is quite simple, right? You just check that. But for objects, right, you actually need to verify if it's in the case of plain objects, you have to verify if they have the same properties and values. So you have to map all of them. So one way to solve that is if you think about it, is that you have to map each one of them and somehow store that information, and then compare that with the second objects if they have the same property and key. And if they don't, well, this is not the same. So because this rely is on iterate through these objects, and if the length of those objects are different, right, of course that's not the same, but again, in any case, if they have the same length, you have to go over all of this. And this is something that might be quite expensive, because the longer the or the bigger the objects, the more time it takes to process that. You might find some other algorithms to handle that, but it turns out that React say no. Instead, always give me is a new state of this application, or a new object that contain is the new value here. So this is why when dealing with complex objects, or even with primitive, we always return is the new state, right? And there is a particularly pattern to handle that. So we store this new state in a new variables, and then we pass that variables, that updated value, to the setter function, and so on and so forth. Also, I look at how you can now manage is this dynamically generated ID. For example, when you're rendering a collection of elements. So what are the use cases to do so? For example, with math.random, or with crypto.get.random's UUID, get.random values UUID. This actually guarantees that those IDs are astronomically low. So they guarantee that these values are unique, okay, or the chances are they have the same value is astronomically low. That was also quite revealing and interesting. So in any case, and then I also, which is part of this hook as well. I also look at lifting the state up. So why do we have here? This is how you can organize your components as a way to now share some piece of information across different components. And when that state updates, well, it's going to now update all of the React children components as well. Uh, so that was quite revealing, right? And talking also about the components instance, right? And from that, React has changed a lot, and it means that this instance is something that so elements don't create instance, rendering does. So in other words, here, as you can see, so elements doesn't create instance of this component, is the rendering that is React that is doing that is doing so, like this, right? Is React that is creating those instance is those JSON object for us. And then now some management tool here, depend on your use cases, you might use or go with some of those state management, whether it's Redux or Substance or you name it. But the thing here is, when you don't have too much state, for example, when you don't have app level state, so landing pages, or so for example, like landing pages. So landing pages or pages that doesn't have any too much interactivity, you don't rely on this app level state. You can easily go with this UI state. However, when you have now heavy intense client-side applications, so games, or that rely on a lot of interactivity, all right, a lot of Javas that rely on a lot of user interactivity. So that makes a lot of sense to have now some sort of management state here, or when you need to store a lot of piece of data on the client. So this is when it makes a lot of sense to go with, right? And then the other is that what happened when now the state of your application doesn't live too much on the client, but live is on the server, aka you are now have to pull a lot of data from a database and then do some data treatments to send back to the client, right? SaaS applications are the most common one, right? And SaaS applications like courses, admin dashboards, even Facebook, right? So when all of those data are now hosted in a database, and the state is hosted on a database. So if you don't have too much state, so you don't rely on this app level state management. But if you have to build some sort of heavy intense task, well, it makes a lot of sense to have now some client-based state management. And the other is, which is exactly what happened here, is now your server, is now your SaaS manage a lot of this state on the server, okay? It makes a lot of sense to have some way to manage that. So for example, we have a bunch of complex data in a database, and our app fetch that data and present it to the user. These applications are essentially interface that lets user read and manipulate data that live on a database. That's the TLDR of this server state or the SaaS application. Hey, the information live in a database, and you're creating now some interface that the users can read and interact with this data. That's all. So this is a broad category of most crude, right? An app fits into it, including most SaaS applications, social networks, search engines, e-commerce sites, and so on and so forth, right? So, all right, now that we have defined this category, let's talk about why they matter. So, so according to Josh, the instructor of this, so formerly he was a software developer at Khan Academy for a couple of years, and then at Gatsby until he finally decided to make this, right? So for most category, most static website category, they don't really have, or they don't really need to have a global state, all right? It is a pretty straightforward on that. For the client heavy applications, of course, and you need to have some sort of Redux or some sort of app level state, right? However, things get interesting when we talk about the server heavy application in category 3, which is what I'm going to build for a particular client. Okay, so the biggest state related challenge in this category are all network related, and all of this network related is that, do we have the data in the right time? Can we now store this data somehow so we don't have to query the data and only do that when they change? Okay, so fetching the right data at the right time. Exactly, so only fetching is the proper data, only fetching is the right amount of data, so we don't consume a lot of bandwidth here. That's one. So network related. The other is make sure that the data doesn't grow stale by revalidating it, fetching it again, and customizing the revalidation for the specific situation. The other is catching the data so that multiple components don't repeat requests unnecessary. Okay. The other is the optimistic UI updates so that we predict how network requests will be resolved. And pagina, okay, this couple of stuff are actually what I'm facing right now. Okay, fetching the right data at the right time, making sure the data doesn't grow stale by revalidating it, fetching it again, and customizing the revalidation for the specific situation, and catching the data so that multiple exactly. So one of them is fetching the data at the fetching the right data, exactly, fetching this right data at the right time. Make sure that the data doesn't grow stale, aka customize when to revalidate that. Again, something that we got to deal with. The other is catching the data. Okay, so to avoid repeated requests, especially in components. The other is the optimistic UI, is that so we can predict how network requests will resolve. And the other is pagination, requesting a small slice of the data and letting the user pull new data as needed. And here's the thing, Redux doesn't really address any one of them, because at the end of the day, React or Redux is just to handle state at the client side, right? It's a state management tool, not a network tool. And over the past few years, several tools has popped up which are purpose built to help us manage this sort of network related challenge. So for example is, and I do get it. I do get it. Okay. This network or network request related challenge. So this tool include Apollo, React Query, and SWR. This is why they use now Apollo for that. Apollo Graph, React Query, or SWR from Vercel. Interesting. Okay, so anything that is related to network requests, network problems, okay, Redux doesn't solve here. Again, because React now, or because Redux has expands to cover these use cases with React toolkit, all right? But it is a state management tool, not a network tool. Mm-hmm. And here is where the demand is. If you're building a video game or an audio editor, Redux is great. But most of us aren't building those sort of applications. Most of the time we're building is now SaaS applications. So back office applications, server state apps. I'll guess that 95% of the React Play applications are either category 1 or category 3. Whether it's an no state or not much state, or mostly server state. Holy moly. And so on. This is the mental model I use when figuring out of which tools to use. If it is a static website like my blog, I use React alone. Okay. With the help of context, of course, that help you to now is store some app level state and share that down the way. If it is a client heavy site application, exactly. If it is a client heavy application, like some sort of level editors, a collaboration tool like Figma or any other tool, so yeah, Redux is helpful here, or an state management here. If it is a server heavy application where the problems here is not how you're gonna state, how you're going to store this data on the client but not on the server, okay, is that how you can pull the right data at the right time, how you can catch that data that doesn't grow stale, and then revalidate when needed, how you can is manage requests or avoid unnecessary requests, as they mention here, right? So how can I avoid unnecessary requests by catching the data here? How can I resolve how network requests, exactly, how to resolve network requests? And then the other is the pagination, is how can I pull data at chunks? Yeah, how can I pull a bit of information here? Mm-hmm. Okay. Okay, makes a lot of sense. Makes a lot of sense. So all of these are, again, I just make that quick recap, but all of these are network requests, not a state problems, or not state management problems. Okay. Okay, makes a lot of sense. If it is a server-heavy application like this core platform or any SaaS application, I use React plus something to help me with the network stuff. I'm using Versal AWR on this course platform. I have no complaint. This is the formula I have found work best after years of experience and dozens of projects, but a lot of this really comes down to subjective preference. But here is something I can say pretty objectively. React has evolved tremendously over the past few years and has become way more capable. You can absolutely build large sophisticated applications without any other state management libraries. You don't need Redux and you shouldn't feel pressure to learn it. The reality is that the market doesn't care. Do you know this? If it is, good. If you don't, period. This is to make you feel better. This is to make you feel better. And I am not in that business. I am the business of telling what works, telling what it is. If you're new to React, here's what I suggest. Spend a year or two getting comfortable building apps with React using the tool covering in this course, and you can always explore Redux in the future and see if you find it helpful. Honestly, there aren't very many wrong ways to build apps. We live in an era of abundance and there's a lot of amazing tools. The most important thing is not to become overwhelmed by trying to learn everything at once. Understand what the problem is. Understand what the problem they are solving. That's it, man. And all of that say, there is one more wrinkle we shall talk about, Redux Toolkit. right? So now Redux Toolkit, right, is to handle this network related problems, right? So over the past few years, the Redux team has been hard at work creating Redux Toolkit, an opinionated toolset that aims to sand down. Okay, sand down. It's like sand down. To sand down. In Spanish. The hell is this? In Spanish, sand down. Como asentar, pulir. Okay. Sand down. Okay. Oh my God, sand down. Okay, that aims to sand down. All right, to polish. But they don't mention polish. To sand down. Okay, okay, okay. Okay, this is English. Sand down, man. Okay, okay. Over the past few years, the Redux team has been hard work at working create Redux Tool, an opinionated toolset that aims to sand down some of the rough edge of working with Redux. This toolkit includes a project RTK query, a tool which is more or less a Redux compatible version of React query or SWR. And again, the problem they're solving is this network related stuff. When you're building applications that most of the state live on the server. I will be pretty excited about this development, but unfortunately I have fundamentally disagree with the opinions that are baked into React Toolkit, into Redux Toolkit. I'll share my quibbles. Quibbles. Oh my God, this is so Canadian. Yes, it is. Quibble. A trivial matter of minor concern raised in arguing or finding fault. Quibbles. In Spanish, quibbles, una objeción de poca monta, algo trivial, ok, algo trivial, discutir por nimiedades. That's right, quibbles, ok, una trivialidad. I'll share my quibbles below for anyone curious, but the takeaway is that I plan on continuing to use classic Redux with our Redux Toolkit. If you're already using Redux Toolkit, I think RTK query is a slam dunk. It makes way more sense to use something tightly integrated rather than trying to get Redux and SWR to play nicely together. Otherwise, it is hard for me to say whether you should use this combination over something else. It wouldn't be my first choice, but I say above, there are a lot of great options nowadays, and this one might work best for you, depending on the type of app you are building and your subjective preference. My quibbles with Redux Toolkit. So as I mentioned above, Redux Toolkit is an opinionated set of tools built on top of Redux, which enforce a number of conventions. Regrettably, these conventions are not well aligned with how I personally prefer to use Redux. I will say before anything else that a ton of respect for the work of Redux team has done, and you should take everything I'm about to say with several large grains of salt. Which large grains of salt, exactly. Take my word with a large grain of salt. Okay, with a large grain of salt. I could very well be an outlier, but in large, the community seems happy with Redux Toolkit. So Redux, there are two distinct concepts, actions and reducers. Exactly. So actions is tracking things that happen. User submit form, timer expire, or network request completed. And reducer, so responds to those actions by changing its state in some way. Okay? In classic Redux actions, we were to semantically distinct from reducers. So reducer is that we respond to that state change. So we respond to that action. Okay, This is relevant because when you're starting to use Apollo, GraphQL, and so on and so forth, they use concepts like this, all right, reducers and mutations. So reducer is like your controller for MVC, aka is going to be responsible for changing the state of the app in some way based on an action, aka based on user submit or a form, user submit a form, time expire, network requests, right? If those actions are now keep track of this, okay. It was seen as a bad thing if your action has set in the name, set user data, because actions are supposed to describe events. Exactly. So actions are supposed to describe the event, not dictate what those events affect. So the reducer is the one who decides what impacts the action has on the state. This clean division of responsibility is, in my opinion, the secret sauce in Redux. That the things that make it great, a single actions like logout might affect the user reducer and also season reducer. So we can watch the streams of actions to get a bird's eye view of what's happening in our okay. So we can watch the streams okay. So we can watch the stream of actions to get a birth okay. So we can watch the streams of actions to get a bird's eye view of what's happening in our app. And we can console with the reducers to see what impact those actions have. In Redux Toolkit, actions and reducers are grouped together in slice. For example, a shopping cart slice will be combined both the reducer branches that change the state and the actions, and each slice has its own exclusive actions. As a result, actions has become okay. So in Redux Toolkit, actions and reducers are grouped together in slice. For example, a shopping cart slice will combine both the reducer branches that change the state and the action. So each slice has its own exclusive actions. As a result, actions has become glorified state setters rather than being broad description of events. This probably doesn't sound like a big deal, and it is impossible for me to explain if you haven't worked in a large classically structured Redux app, but honestly, it is totally at odds with how I think Redux should be. I will not enjoy using React in this way. I do understand why React's team had made this change, as I mentioned in the first complaint about Redux, too much boilerplate. But consolidating action and reducer, it means the developer doesn't have to hop between an action.js file and a reducer.js file, and they spend less time writing code. But here's a question: is the boilerplate really that bad? I mean, it must be if it is the first complaint, right? But think about it. If Redux was offering a ton of value, if it was indispensable part of your stack, would you really mind spending a few seconds now and then creating explicit actions? When I work at Khan Academy, we use Redux, and honestly, I didn't add much value for us. We didn't have tons of global client side. Okay. We didn't have a ton of global client sites, and so it kind did feel like we were spending too much time on Redux boilerplate relative to how much value we're getting from it. When I work on an app with a lot of client-side state, however, the boilerplate is absolutely trivial compared to the amount of benefit I get from Redux. It is not even close. But a big part of why Redux is helpful is the crystal clear event log. By squashing actions and Reducer together, we send away one of the most useful part of Redux. And so I'll continue to use classic Redux in my client heavy project, and I'm happy to keep creating explicit actions. But it all boils down to the separation of concern of what an action and a reducer is. So a reducer is responsible for change the state in some way based on an action, based on or what happened, what are the things that happen. Okay, and in this case it can be several things, it can be several events here. So it makes a ton of sense, because when you're writing client-side applications, you might define your custom actions or custom events, all right? And you're building now is event-driven applications, data event-driven applications. Okay, all right, okay. So why I hit the brake here? Well, because this is all part of the things that is relevant when building applications like that, all right? And how to handle that, right? And how to handle that. And well, some input cheat sheets, right? And how you can handle this kind of stuff, and so on and so forth. So you get the idea here, right? Specialty inputs here. Exactly, right? And it is keep tracking when that color stay update as it is, and they show that proper color as it is. So okay, and then I went through creating this word game that was quite interesting, in order to understand how you can build this kind of a small user interfaces, provide some interactivity to these components, and to keep track is when a state change here, right? So that wordly, I think, let me show you that. So wordly, this is it, right? This is the project. As you can see here, is this one, right? And say, hey, this wordly is again for guessing 5-character, is giving 6 attempts to figuring out a 5-character word, all right? And now it's generating is a new dynamic, and it's generating on any refresh or anytime that you get into this website, it's generating a new hidden word, right? As you can see, it's going to highlight is in orange or in green if those words actually are part of the word. Green is that indicate, hey, this is the right position of this word, and orange say, hey, this is the right word but not in the right spot. Okay. So I'm not sure what is the word here. It's a word, hello there, word, and it ends on O and D. What it'll be is, oh my god. Let me see if I can get this. Hello, it's bore. That's right. So I put that here so you can actually see what it is. So it is bore, right? And there you go. Right? You guessed that in 3 attempts. So there is a lot of things involved. The first thing first is to understand when you're building anything, particularly a program. It's important to specify is the inputs and the outputs, and define some sort of a naive approach, describe what are the trade-offs, and then iterate on that, right? And if you find in that algorithms new problems, so define the input and outputs, and then define a small naive approach, and so on and so forth until you get something. And once you get something, you define is a trade-off here. I think this systematic thinking is important when you are not only building this kind of application, but for any problems that you might encounter in your life. In any case, this is the war game, right? I can leave the link down below. That was quite interesting. And finally, to what is relevant in today's video, which is what are the other tools that React give us to. Because when you have components, and since before React 17, we use now the React create class components where you pass now the state and the handlers, and then the render function, right? So now in React 16 and 17, React say, okay, let's going to define now our component in a class using the class keyword. And it all sometimes quite hard because you need to handle is the value of this and so on and so forth. Again, this is very specific to JavaScript, but in any case, those days are gone. And now the React team say, hey, instead of doing that, let's going to create our components from starting from React 17 to React 18 and so on and so forth. Let's going to now change that way to defining UI in a function as it is, right? So with this approach, when you're starting to now have this one tool of which is the components, so this is when you're starting to see that we use components to not only represent some user interface, but to now represent some data treatment here, data manipulation. So some applications have all of these components that some of them are handling is transitions or authentications or some network calls or some data that we're pulling out of the tree and pass down using context, for example. So none of this actually matters for the UI. They're not relevant. We're using them because this is the only tool that we have to solve this particular problem. This is when now the React team say, hey, instead of reusing components, which it is a good thing, but there are some states or a piece of information that needs to be global here. And this is when they decide to create now something called as hooks. So hooks allow you to hook into React internals, right, to help you solve specific problems. One of them is, hey, when you need to define is a unique identifier across your app using React, let's go to hook into, and this is useful, for example, in attaching is HTML form IDs with that. So anytime that you need somehow to reuse is a component, but somehow those piece of information needs to be global, aka, for example, the ID of the label or the name of the label and the input. So when the user click on that, you can get that. In this case here or here, or even if you click here, it actually send you to that specific location. Okay. So this is why we use now useId. All right. That is quite interesting. It is a very specific stuff. And now, when you use, for example, these hooks in a weird way, right? In a way that you think that they're supposed to work, because after all, we are writing is JavaScript. So sometimes when you're trying to use those hooks, it tells you a warning here of three things. Or you might not use as a proper version of React to render that hooks, or you don't follow is the React hooks, or you might have one copy of React in the same app. So the first and the third is some edge cases, but the second is the rules of hooks. And what in the French toast is that, right? So, but when we call these functions, they hook in React internals, and we can catch React off guard. So this rule of hooks is made of two things. You can this is why we're going to look not at the course, but at where you can find this, which is React hooks. The rules of React. Okay. I think this is the API. Okay, so far we have looked at this state hooks, all right, that allow you to remember something. It relies on closures. When anytime that you want to keep track of a piece of information over time, well, closure is the way to do that, and React is handling that for us and exposing that as this nice convenient functions. Then you also have some other hooks, right? You have now the context hooks. When you want to now share specific data, you have also the ref hooks, all right? When you want to hold now some information across render, and you have the effect hook when you want to connect or synchronize with external services. The performance hooks when you want to avoid unnecessary work, when you want to skip unnecessary work. So for example is using memo or using callback. Or with this too is use memo or use callback. And then some other hooks that are specific to the library. So for example, use debug values that are specific for library author. useId, all right, using external store and use actions. Or even you can create your own custom hook, right? And when you do this, what I'm trying to look is at describing the UI, React compiler, quick start, what the French toast is this? Rules of React. Exactly. Components and hooks must be pure. React calls components and hooks and the rules of hooks. And okay, is this rules of React? All right, makes sense. Okay, rules of React. So it is this, right? So only calls hooks at the top level, and only call hooks from React functions. So the first is, or in this case, they mention is this. So hooks have to be called within the scope of React applications. We can call them outside of React components, all right? Only custom hooks can be called that. And the other is that we have to call our components on the top of the components. So the second rule is the one that treats most people up, even myself. And you can, if you can think of this, right? There are several of those rules that they mention. So if this only call hooks at the top level, and they say, hey, do not call hooks inside of conditions or loop. Do not call hooks after a condition return statements. Do not call hooks in an event handlers. Do not call hooks in a class component and inside function, pass, use, memo, and so forth, or try and catch here. So if you can think of this, right, instead of conditions or loop, why we cannot call hooks inside of this? If you think about this, is somehow sometimes you have hooks and sometimes you don't have them, right? So you are now in a weird state. Imagine that you are now keep trying to understand. Imagine that you're building your own hooks, all right? You want to store this piece of information. In the case of use state, right? But sometimes you have that piece of information and sometimes you don't, all right? So first thing first is that how you can now is guarantee that, okay? And here we're talking about is the stability of that piece of information. How stable is that piece of information in that function? Because sometimes it is and sometimes doesn't. So how you can now keep track of that, all right? And answer that question, it requires a lot of tricky and stuff like that, something that you might or not go with. I definitely don't think that'll be the case. All right. All right. Okay. So yeah, this is the reason why, or this is an explanation of why we have all of these weird hooks here. Is because if you think about it, how you make sure that to keep track of something when you sometimes haven't and when you others don't have, right? And you may wonder, why do I need to keep track of this? Well, because you want is to have certainty. Okay, you want to be this deterministic, so you don't rely on unexpected behaviors, right? A good example of that is if you have a shopping list, right? It is much more easy for you to store that first in an alphabetic order, and second, to have everything that you need, despite even that despite you don't even have or you don't need them. For example, let's say you have now a shopping list, grocery stuff, that you do weekly. Okay, so you want to buy some potatoes, onions, carrot, cabbage, bananas, guavas. Yeah, guavas, high in vitamin C. Guavas and some poultry, if you are a carnivore, or some beans, right? So chickpeas and lentils, so on and so forth. And yeah, so you get the idea. Uh, and then, even though that after the week passed, and sometimes you consume more stuff than others, right? And even though the next week you might not need to buy or to bought something like chickpeas, right? Well, you even though you store that in your shopping list, you put that a value 0, right? So make sure that you say, hey, okay, now from all of this list, I don't need to buy this, but it's there. Okay, it makes you it is make much more sense to keep track of things in this way. This is the reason behind this, right? Why you should put all of your hooks at the top and avoid any of these scenarios here. And that's good. That's quite interesting. That's great. I also look at some couple examples here on how to do so. Absolutely, absolutely. Later in this course, we'll learn how to automatically delegate props in this situation. Okay, so this is the exercise here. Fix the violation here. I already fixed this because, yeah, I already fixed that. Exactly, it's because they put it now in instead of an if statement, so this is not how you should deal with this, right? And you must always make sure that that particular state always exists, right? And well, if this property here, the like this, right? If this property here if this field exists or not, in this case is this, no, because we like it or not, we want to create this, okay, and say, hey, if that exists, exactly, you can call conditionally here. So no matter what happens here, I'm gonna call this, right? Exactly, I'm gonna call this and attach this value, but this is exactly, and attach this value to this. So whether it's this exists or not, I'm going to show that. Yeah, but that is something that I know that it has before, something like that. Exactly, it's because somehow I need to store that data here, okay, and show search field here. So in other words, so I can store this generate ID. I can store this piece of information here, and then on the show field if this is true or false, right? Exactly, if this is true or false, the search ID here, okay, which is the search ID here. So the search ID here, it'll be is whether it's the generated ID. Okay. What am I doing here? That's a good question. I do want to hold this piece of information here, okay, and then on the ID, show search field, okay, and then depend of this value, I'm going to either show that or not, okay. Hey, do we have here? Do we have? Is this value exists? All right, I'm gonna show you this. It'll be something like this. Hey, if this is exactly, is that, or you either do that, okay, or the search ID, or you wrap this component into its own thing, bro. Exactly, or you wrap this component into its own theme, which is search field or search. Exactly, search field or search. Or you wrap this into its own component here. That only show is this. Exactly. It's like you're abstracting this piece of logic into its own. Okay, you're abstracting this piece of logic into its own component. By saying is search input, right? Hold this into a now I prefer to go with a function here, and then do this, right? I'm not going to receive any inputs right now. I just want us to return is this GSX that say, hey, yeah, this is the element here, and then I here want to now is define that state that I need to keep track of, which is this one, right? You can get rid of this, right? And then you define is this as expected. You say, hey, search ID, it comes from the react.useId, right? So if you want to use this, you go here and say, hey, let's go with this component. Let's go with this component here. Okay, so what you did here is if you find yourself that you need to have that stay here and that is colliding abstract that state and put that into their own particular input. Again, if you want to now attach that HTML form with the input here. So in other words, you are now telling React to globally put an ID to this element here. Holy French toast. Fix another violation. Let's do it one more time with a different scenario. In this exercise, our login form component can either render a form including email password field. If the user isn't logged in, a paragraph if they can either render a form including email password field if the user isn't logged in, a paragraph if the user is logged in. Okay, simple. You can toggle between this state by submitting the form. Unfortunately, we're getting a link warning. Your mission is to figuring out what's causing it and to fix it. Accepting criteria. Update the code below so that it doesn't violate any rules of hooks. I do think this is quite revealing. All right, by just putting all of these hooks at the top, right? We solve this issue as it is, right? The error was that, hey, React hook used to say is called conditionally, and React hooks must be at the top in the exact same order in every component render. Did you actually call React hook after an early return? You see, this is great because, again, part of the rules of hooks, your components are okay. So your components, right? So your hooks must be used only in React context, except for custom hooks, something that you define. And the other is that all of those hooks must be at the top of the component here. At the top of your component here. Because of the order. And now they keep track of that. Okay, that makes a ton of sense. Immutability revisited.
So in this module, we're going to talk about some of what I personally think are the hardest things in React. I'm thinking specifically of stuff like the useEffect hook, as well as memoization.
The rule of hooks.
Like, these are complicated ideas that really require a sophisticated understanding of how React works. And one of the most misunderstood things about how React works is this idea of immutability and what it actually means for state to be immutable. And so before we get on to all that really hard stuff, I want to revisit some of the stuff we've talked about around immutability, and I want to go a little bit deeper. So to help me with this, I've created this visualization of the computer's memory. Right? This is one of those RAM sticks that you put in your computer. And I want to show what exactly happens as I create and then update pieces of React state. And so the circumstance here is that I have a single component with a single state variable called user. It's an object that has a name property set to Ivy. And let's suppose I want to update the user's name to Ava. Well, if this was plain JavaScript, I could do it by mutating the object by setting user.name equal to the string Ava. But as we've learned, right, this is a no-no in React. We don't want to mutate state ever. And so instead, if we want to change a piece of state, we have to call the setUser function and provide it with a new object that updates whatever properties and values I want. And when I do that, like if I click this little button over here, what we notice is we've actually created a brand new object that lives in a different box in the computer's memory. Now, I should, by the way, say, I'm not a mechanical engineer. I don't really understand how computer memory works, so this is a gross oversimplification. But the mental model is the important thing, and I feel pretty confident that this mental model is both accurate to a degree and helpful. So let's not get too bogged down in the details about bits and magnets, maybe, and focus on the important stuff, which is the React state. I think the thing that's confusing about this is that I'm not editing this particular object in memory. That would be mutation. But I'm also not like swapping it out, right? I'm not changing the object stored in here from this object to this object. I'm creating an entirely separate object that lives somewhere else. It means that both of these objects exist at the same time, at least for a short while. Like in practice, what winds up happening is when I call setUser and I pass it a new object, the component instance will like update which thing it's looking at, and so the original object will be dereferenced, right? There will be
in this component's instance, that is not by element, is when it renders. When it renders,
no more code that is connected to it, and that signals to the JavaScript engine that, oh, this thing isn't being used anymore, so the garbage collector can come along and sweep it up. I don't want you to think that every time you call setUser, you're filling up your memory with more and more things. Although, if you've heard about memory leaks in React, this is how memory leaks occur. If you have references that continue to reference former values of state, well, that's a memory leak in React, and we're going to talk more about that in a little bit as well. But the core idea here is that I essentially have two different user variables, right? Locally scoped variables that are scoped to this snapshot, to this render, and they each point to different objects. And both of these objects are immutable, right? I'm never editing the object. I'm never reassigning the variable, right? For the end of time, this user variable will point to this object. And so when we say that we're changing the state, it's really more like we're painting a new picture with a new value. And this is true, by the way, even if the new value is structurally identical. So let's say that I call setUser again, except now I pass it a new object that is totally the same as the old one, right? Both of them only have a single property name set to the same value of Ava. And even though they look the same, they are not the same, much like how identical twins look the same, but they're still two distinct people, right? When I call setUser, I hand it a new object, right? It's me, the developer, that's actually creating these objects. And so the moment I do that, the moment I create this object, it's going to be stored in memory. And it doesn't matter that there's some other object in memory that has the same shape. All that matters is I've told React, hey, I'm changing the user object. Here's the new object for you to use in the next snapshot. Now let's consider how this works if we have multiple state variables. And so once again, we still have a user named Ivy, but now I have an items state variable which holds an array of numbers. And for the first render, right, we go through the code, we initialize this object and attach it to the user variable, and we do the same thing for the array. So I have these two different entities in memory. And let's suppose I go through the same process of calling setUser with a handful of new objects. Well, as we've seen, right, every time I create one of these objects and hand it to React by calling setUser, I get a new object that lives somewhere else in the computer's memory. But notice what's been happening with our items array. Each of these snapshots points to the exact same array. And to be clear, I'm still generating a brand new items variable in each of these snapshots, right? I have that line const items equals react.useState. Each of these items is a different locally scoped variable, but they all point to the same underlying reference. I only have one array of numbers, and it's being threaded through every single snapshot. This is kind of amazing, and I wanted to bring it up both because I don't want you to think that every snapshot is like a brand new clean slate where everything is copied and unique and distinct. Like we do thread values through unless they change, unless we're changing them and passing them to React. But I also wanted to point this out because it's fundamental to how a bunch of things in React works. Like in this module, we're going to talk about effect dependencies and memoization. And to understand these things, you have to understand the difference between two items that look kind of the same but are referentially different versus the same reference that's being threaded through. And there's a perfect example right here. If we look at these final two snapshots, right, the snapshots look identical. Like in both cases, neither of these state variables appears to have changed. In snapshot number 3, I have a user whose name is Ava and an items array with a single digit in it, number 1. And in the fourth snapshot, I have exactly the same stuff. But if we look at the references, right, I see that the user object, the user variables, point to different entities in memory. They look the same, but they are distinct things like identical twins, whereas the items array are both references to the same underlying thing. Even though they're different variables, they hold the exact same entity. They both point to the same thing. I know that this all probably seems very abstract and high level, so I've also created a code playground that lets us tinker with these ideas up close and personal. And to give you a quick rundown of the setup, I have a user state variable that is this object, right, just like in our visualization, and I have a button I can click which will generate a new user object and randomly select from one of these short names that could fit in my visualization. And I call setUser with this new user object, but then I also keep track of every value that is created by clicking on the button. I have this state values array. I'm attaching it to the window so that I can access it in the console. I'll show you that in a second. But effectively, it's a typical React app that keeps track of all of the different state values in this array. So let's say I click the button a few times, I see the name changing down over here, and if I open the console and flip so that I am accessing the console for this iframe, right, I have to do that, otherwise it would be running in the main course platform window. In this window, if I try to log window.stateValues, well, check it out. It's an array of 6 different objects, and they're still alive, right? They still exist because I've kind of kept them alive by putting them in this array. But I can see that they are distinct things. I'm not modifying a single object across all of these snapshots. I'm creating new objects, so we actually see that right over here, right? Here is where I create the object and store it in memory, and then here is where I tell React to retry everything, right? Generate a new snapshot, but now this new user state variable should be equal to this object rather than the initial object it was set to for the first snapshot. So I hope that this makes a little bit more sense. I do realize, like, this stuff is hard, and I don't expect you to have that concrete, crystal clear understanding just yet. But hopefully these ideas can percolate in the back of your mind as we go through some of the ideas in this module. And if you ever do find yourself struggling to understand some stuff later in this module, I think it might be helpful to rewatch this video and tinker with some of these things yourself, because I think at the core of so many of the things we're going to talk about in this module is this idea of immutability and how data is passed between snapshots.
What are these snapshots exactly? I show a snapshot which appeared as car containing pieces of a state. In this course, I use the term snapshot to reference to mean the result of performing a render. Exactly. It is a combination of two things: a specific value in any prop state at the time that render occurred, and the React element returned from the component describing the UI calculator in the render. My demonstration above doesn't show the element since we are focusing on the state, but it might be worth it to revise the code React loop for that. Tiki. We might also be wondering what's the difference between snapshot and instance. The snapshot is the end result of calculating the current state of that component given the props and the state at that moment. And the instance is when it is created. As we learned in the component instance lesson, a component instance is a JavaScript object that is the source of truth for everything related to a particular instance of that component. It is created when the component is mounted and it persists until the component is unmounted. A snapshot, by contrast, is not a specific JavaScript object. It's more an abstract metaphor concept, and it refers to data available at the moment in time. Or the specific information at that moment. So we might say that instances hold the true value of a piece of a state, but every time the state changes, we create a snapshot that captures the current value of that state variable. I realize that I throw a lot of terminology at you in this course: components, elements, instance, and snapshot. And it is okay if these concepts aren't fully settled in your mind. Our goal is to slowly build confidence in our understanding as we learn more and more about React. The React docs help solidify is this. So the instance and the snapshot here. Exactly. So the instance and the snapshot here. And then we look now at ref, another hooks. Okay. So typically as web developers, we build user interface out of a standard set of DOM primitives, div, button, forms, etc. But there was also come with totally different ways to draw UI, HTML canvas. If you're not familiar, HTML canvas offers a Microsoft Paint style ability to create graphic by drawing shape. I use it on my blog to create this little fun magnetic shaping. In order to work with HTML canvas, we start by rendering a canvas tag and then running a bunch of commands on it using JavaScript. It might look like this. And so you pick up the canvas, you started to create the content where you want to draw, and then draw stuff there.
So it's easy to forget when I write a bunch of JSX like this that I'm not actually creating HTML DOM nodes directly, right? Like this is not HTML. And if we were to transpile the JSX, we would see that it's a function call to react.createElement that produces a JavaScript object. This abstraction, right, the fact that we write something that looks like HTML but is actually JavaScript, and then React turns it into actual HTML. That distance between what we write and what we get is a wonderful thing about React, but it does introduce some challenges when it comes to us actually needing to interact with these DOM nodes. In the case of Canvas, I have this big string of commands that will paint a hopefully familiar shape, but in order to run them, I need to get a context, and in order to get a context, I need to have a Canvas element. Now I could use document.querySelector. There's nothing illegal about it, but it's generally a bad sign if you find yourself doing this because it means that you're reaching around React's abstraction rather than trying to work through React. It can also lead to some bugs, like if I run this code exactly, it'll work right now because I only have one canvas tag on the page. But if I had multiple instances of this art gallery component, it would start to fall apart. Now I could fix that by giving this canvas a unique ID. Maybe I could use the useId hook, but there is a better and more conventional way to do this, and that is to use the ref attribute. Now the ref attribute is a little bit like key in that it is a special React thing. It won't literally be applied to the DOM node that gets created, nor will it be passed as a prop if this was a component. Instead, it signals to React that we want to do something a little bit special, and it works in a number of ways. One way to use it is to pass it a function, and React will call this function for us and provide us with the underlying DOM node. So if I add that parameter and log it, and then check my console, I notice that I see the actual canvas element, the same thing I would get if I called document.querySelector. So that's one way we can get at the underlying DOM node, and then I could update this function so that instead of looking up the canvas directly, it takes canvas as a parameter, and then I can call the draw function, passing the canvas in, and voila, a Pokeball appears in the canvas. Now, I'm happy that this is working, but it's not actually the user experience that I want, right? It's being painted immediately because the way React works is it calls this ref function whenever this component renders. What I actually want is for the canvas to stay blank until I click the draw button, and then I want the image to appear. And so I know that I'm going to need an on-click handler, and I want to call the draw function when this click handler is invoked when the user clicks the button, but I can't really do it by moving the function down here. If I try to do this, well, I'm going to get an error because canvas is not defined, right? I've only defined it within the narrow scope of this particular function. What I need to do is create a variable, we'll call it canvas. Maybe I will rename this parameter to be ref so that inside this function I can set canvas equal to ref, and now it should work. Now I'll be honest, I did not expect this to work quite as well as it does. Like I thought it would work, but I thought there would be problems if this component re-renders. It turns out it actually works quite well because on every single render I create a new variable, I rerun this function which captures the reference again and assigns it to this new variable, and then it works when I call draw. But this process of doing the lookup essentially on every single render and assigning it, it's not super quick. Like there's always going to be a performance cost when we're doing anything with DOM, even if it's just looking something up. It would be better if we were able to capture a reference to this canvas tag on the very first render, and then reuse that work across subsequent ones. And so even though this works perfectly fine in this situation, I don't think I've ever seen anybody actually do it this way, just because there is a more conventional approach, and that more conventional approach is to use a hook we haven't seen yet called useRef.
So use ref.
We're going to assign this to a new variable called canvas ref. And the idea with refs is they're sort of like a box, and we can put whatever we want in the box, and then React will thread this box through every single render so that I always have access to it. By default, it creates an object with a current property set to undefined. And sort of like the useState hook, I can pass an initial value if I want, and then that will be sort of what it initializes as. If I leave it blank, it initializes to undefined, but that doesn't actually matter because almost immediately I'm going to put this underlying ref inside that box. And I could do that by setting canvasRef.current equal to ref. I don't want to reassign this variable. I want to mutate this object so that current holds that canvas tag like this, but there's a more performant way to do this. I can pass the canvasRef object directly to the ref attribute. Now I know I just made a big deal in a recent lesson about how we aren't supposed to mutate things in React, and in this case we are doing exactly that. Like I have this object, and I am updating it so that the current property goes from being undefined to holding a canvas tag, but that's the thing that makes refs different from state. React state is always supposed to be immutable, but React refs are intended to be mutated. And so essentially what I'm doing here, it's not that different from what I was doing before, where I'm creating a variable, it's wrapping it in an object. That object starts as undefined. Then I am capturing a reference to this particular DOM node by setting the ref attribute, so we now capture the canvas in there. And then to actually draw to the canvas, I'll pass this in, making sure to select the current property because I want to pass the underlying canvas reference in and not the entire object. And when I do this, I am able to recreate my Pokeball in a conventional and appropriate way.
Not just for DOM nodes, but any of piece of information that we want to store across render. Okay, we want this in this box: DOM node, numbers, array, object, functions. But it's any piece of information, any value. Let's say the primary use case for ref is to store DOMs, but it's pretty rare for me to need to store anything else in a ref. Exactly. So that'll be all for this video. Take care. Bye-bye.